The story of the rebuilt Bugatti Chiron Sport is one of the most extreme automotive rebuild projects ever seen, and it has now reached a stage where it is almost complete. But the final steps are the most critical ones. This car, a Bugatti Chiron Sport, was once heavily damaged in a crash and was believed by many experts to be beyond repair. Even the company Bugatti itself had made it clear that rebuilding such a machine outside their official factory would be nearly impossible. There were no official repair guides, no support for parts, and no clear instructions for how to bring the car back to life. Despite all of this, a dedicated rebuild team led by Armstrong continued the project for over a year. The goal was not just to repair a broken supercar, but to prove that deep engineering skill, patience, and creativity could overcome limits set by even the most advanced car manufacturer in the world. What makes this story so powerful is not just the car itself, but a journey of rebuilding every single part from scratch or repair, often without any factory support. The car was split apart, structural damage was repaired, and critical systems were rebuilt one by one. Slowly, what once looked like a total loss began to take shape again. At this stage, the car is already running, which alone is a huge achievement. The massive W16 engine has been started successfully, and the gearbox shifts through gears without major issues. Even the interior, which is extremely complex and luxurious, has been rebuilt with custom work and careful attention to detail. The project has now reached around 90% completion, which means most of the impossible work is already done. However, the final 10% is where things become more delicate and unpredictable. This is the stage where small problems can become big setbacks, and where success depends on precision, testing, and approval. The story is no longer about whether the car can be built, but whether it can be fully completed, tested, and made legal for the road. This final phase is what separates a workshop-running project from a fully road-legal hypercar. One of the most important parts of the rebuild process has been the restoration of the car's mechanical heart, especially the W16 engine and all supporting systems. The Bugatti Chiron Sport uses one of the most complex engines ever built, and rebuilding outside the factory is an extremely difficult task. In this project, the engine was carefully reinstalled, checked, and started successfully, which was a major turning point. It showed that the core engineering of the car was still alive and functional. Along with the engine, the gearbox system also needed careful attention. A damaged mounting bracket that many experts believe could not be repaired was actually rebuilt and reinforced through skilled fabrication work. This part alone became a symbol of how far the project had come, because it proved that even critical structural components could be restored instead of replaced. Cooling systems were another major challenge. The car uses multiple radiators and cooling circuits to control the heat of the engine, turbo systems, gearbox, and electronics. Some of these radiators were custom-built using adapted cores and modified fittings. During testing, a small leak appeared, which had to be diagnosed and repaired carefully before moving forward. Even though this might sound like a small issue, in a hypercar like this, every leak or fault can affect the entire system. The repair process showed how detailed and careful the team had to be, since even transport damage could affect performance. At this stage, everything mechanical must be tested step by step, because a car cannot move forward to final assembly or road testing until every system is stable. The success of these mechanical repairs is what allowed the project to reach the 90% completion stage, but it also sets the stage for the most important testing phase that comes next. Without stable mechanics, the rest of the rebuild simply cannot succeed as the rebuild moved forward. One of the most sensitive and important stages became the cooling and temperature testing system, which is essential for the survival of the engine. In a car like the Bugatti Chiron Sport, temperature control is not just a feature. It is a life or death requirement for the engine. The system contains multiple cooling circuits that manage different parts of the car, including the engine, turbochargers, gearbox oil, and electronic systems. These circuits must all work together perfectly to keep the car stable under heat and pressure. The process of filling the system is not simple. It must be done under controlled conditions to remove all air pockets, because trapped air can create dangerous hot spots inside the engine. These hot spots can lead to overheating, seal failure, or long-term damage. This is why the system is often filled using vacuum techniques to ensure complete fluid coverage. During this stage of the rebuild, even small mistakes could lead to serious consequences, which is why experienced specialists are involved in the process. One key moment in the story is that the engine had previously been run under uncertain conditions, which raised concerns about possible hidden damage. Because of this, the temperature test becomes even more important. When the engine is started again, several things must be monitored carefully: the temperature rise, the oil condition, and the behavior of the cooling system under pressure. Clean oil and stable temperature readings would indicate that the engine is healthy, while signs like overheating, contamination, or bubbling in the coolant system could indicate serious internal issues. These tests are not just technical steps. They are the final confirmation of whether months of rebuilding work were successful. Every reading tells a story about what is happening inside the engine, and every result determines the next step in the process. At this point, the entire project depends on these results, making this one of the most important stages in the entire rebuild. Another major part of the final phase involves exterior assembly and bodywork, which brings the car visually back to life. While most mechanical systems are already functioning, the car is still not fully complete in appearance. Several body panels are either missing or temporarily fitted, and some sections still require proper alignment and finishing work. Paint work is also needed in areas where repairs or structural changes were made during the rebuild. This stage is not as mechanically complex as the engine or gearbox work, but is still extremely important because it affects both the look and the aerodynamic performance of the car. The process must follow a strict order, starting only after all mechanical systems are confirmed to be stable. This is because it would be a waste of time and effort to complete paint and final body assembly if the engine or cooling system still requires removal or repair. Once everything underneath the surface is confirmed, the car begins to take on its final form. This is also the stage where the project becomes visually satisfying, as the damaged and partially assembled machine slowly transforms into a complete hypercar again. The exterior design of the Chiron Per Sport is very precise, so even small alignment issues must be corrected carefully. Every panel must fit perfectly, and every surface must meet the original aerodynamic design standards. As the bodywork progresses, the car starts to look less like a rebuild project and more like a factory-finished vehicle. This transformation is important not just physically, but emotionally as well, because it represents the shift from repair work to completion. At this stage, the project begins to feel real, as if the impossible goal set at the beginning is finally becoming reality. The legal approval stage is another major challenge that determines whether the rebuilt Bugatti Chiron Per Sport can actually be driven on public roads. Even if the car is fully functional mechanically and visually complete, it still must pass strict inspection rules before it can be legally registered. This process includes an individual vehicle approval inspection, which checks safety systems such as brakes, steering, lighting, emissions, and structural integrity. Because this car was heavily damaged and rebuilt outside the factory, inspectors will closely examine key repaired areas. One of the most important points is the repaired gearbox mounting bracket. Since it was welded and reinforced instead of replaced, it must be proven that it is safe for long-term use under extreme conditions. Another focus is the exhaust system, which was modified during the rebuild. It must meet noise and emission standards before approval can be given. The structural repairs to the chassis are also heavily inspected, especially the section that was cut and rejoined during the rebuild. These areas must show that they are strong enough to handle high speeds and stress. If any of these checks fail, the car cannot be registered. This is why this stage is considered one of the most stressful parts of the entire project. The outcome depends not only on the quality of the work done, but also on how the inspectors interpret the repairs. Even with perfect engineering, approval is not guaranteed. This is a final gate between a workshop project and a road-legal supercar, and passing is essential for the story to reach its true ending. The final and most uncertain challenge in the entire rebuild is the electronic control system reset, which depends on manufacturer-level access. Modern hypercars like the Bugatti Chiron Per Sport rely heavily on software systems that control everything from engine performance to safety functions. After a crash, these systems often enter protective state, storing fault codes that must be cleared before the car can be fully approved for road use. The problem is that clearing these codes requires special diagnostic tools that are only available through authorized channels. In this case, access to Bugatti's system is controlled tightly, and independent builders do not normally have permission to use it. This creates a major obstacle at the final stage of the rebuild. Without this reset, the car cannot pass inspection, even if all mechanical work is perfect. This makes the situation especially tense because everything else has already been solved through engineering skill and fabrication. The only remaining barrier is software access and manufacturer approval. At the same time, legal changes and repair rights are slowly shifting the industry, which could influence how such systems are accessed in the future. This adds an extra layer of uncertainty, but also possibility. The outcome of this final step would determine whether the car becomes fully road legal or remains limited to private use. Once the system is cleared, the final step is registration, which gives the car official identity, license plates, insurance, and legal permission to drive on public roads. At that moment, the rebuild will be complete, and the car that was once considered impossible will finally return to road as a fully functioning machine. The final phase of this Bugatti Chiron Per Sport rebuild also brings a strong emotional and psychological weight that goes beyond engineering and technical work. At this point, most of the physical challenges have already been solved, but the pressure is actually higher than at the beginning of the project. When the car first arrived in a damaged state, the expectations were low, and almost everyone believed it would either be impossible or extremely limited in outcome. But now, after months of progress, the situation is very different. The car is not just partially working. It is almost fully complete. This changes everything, because now every small issue feels more important. A tiny leak, a software fault, or a failed inspection test could undo weeks of progress. This is why the final 10% of the rebuild is often the hardest part of any large engineering project. It is not because the work is more complex than before, but because the margin for error becomes extremely small. The team working on the car must stay focused on details that would normally not matter in earlier stages. Every bolt, every connection, and every sensor reading can now influence the final outcome. At the same time, there's also a strong emotional reward building up. After so many months of effort, seeing the car move, start, and function gives a sense of progress that is rare in large engineering projects. It is no longer just a broken supercar in pieces. It is a functioning machine that is close to being fully reborn. This creates a mix of pressure and excitement, where every step forward feels like a victory, but every problem feels like a possible setback. This emotional balance is a key part of why such rebuild stories are so engaging for viewers and followers. They are not just watching a car being fixed. They are watching a long, uncertain journey where success was never guaranteed, and where the final result still depends on a few critical steps. Another important aspect of the final stage is a testing and validation process, which ensures that every system in the car works together correctly under real conditions. Even though individual systems like the engine, gearbox, and cooling circuits may already function properly on their own, the real challenge is making sure they all work together without conflict. In high-performance cars like the Bugatti Chiron Per Sport, systems are deeply interconnected. A change in temperature can affect engine timing, gearbox shifting, and even electronic stability controls. This means that testing cannot be done in isolation. It must be done as a full system test. During this phase, the car is carefully monitored while running at different temperatures and loads. Engineers observe how quickly the engine reaches operating temperature, how stable it remains under pressure, and whether any warning signs appear in the electronic systems. One of the most important checks is consistency. A single successful run is not enough. The car must perform reliably multiple times under similar conditions. This is because hidden issues often appear only after repeated stress, not during a single test. For example, a small coolant imbalance might not show up immediately, but after several cycles, it could cause overheating in specific parts of the engine. Similarly, electronic faults may only appear when multiple systems are active at the same time. This is why testing takes time and patience. It is not about speed, it is about certainty. Every result must be recorded, analyzed, and confirmed before moving to the next stage. This careful process is what transforms a repaired vehicle into a fully reliable machine. Without it, the car might work temporarily but fail under real-world driving conditions, which is not acceptable for a vehicle of this level as the rebuild reaches its final steps. Attention also turns to the legal and regulatory side of the project, which is just as important as the mechanical completion. A car like the Bugatti Chiron Per Sport is not only a technical machine, but also a legally regulated vehicle that must meet strict government standards before it can be driven on public roads. This means passing inspections that evaluate safety, emissions, and structural integrity. One of the most important challenges in this case is proving that a heavily modified and repaired supercar still meets factory-level safety standards. Inspectors do not focus on how difficult the rebuild was. They focus only on whether the car is safe and compliant. This creates a very different type of pressure compared to mechanical work. For example, a repaired chassis section must not only be strong, but must also demonstrate that it behaves correctly under stress. Similarly, modifications to exhaust systems must still meet legal noise and emissions limits, even if they improve performance or were necessary for repair. The inspection process is detailed and often strict, leaving little room for interpretation. Every system must be documented and explained clearly, especially because this car was not repaired through official manufacturer channels. This makes evidence and testing results extremely important. In many cases, even a perfectly working car can fail inspection if documentation is not strong enough or if a system cannot be verified properly. This is why the final approval stage is not just about engineering success, but also about communication, proof, and compliance. It is a point where technical achievement meets legal reality, and both must align perfectly for the car to be approved. The center of the final challenge, is also the dependence on manufacturer-level software systems, which represent one of the last barriers between a completed rebuild and full road legality. Modern hypercars like the Bugatti Chiron Sport rely heavily on electronic control units that manage almost every function of the vehicle. After a major crash, these systems often lock into a protective mode to prevent unsafe operation. Clearing these fault states requires specialized diagnostic tools that are typically only available through authorized service centers. This creates a situation where even a fully rebuilt and mechanically perfect car cannot be fully approved without access to proprietary software. This dependency highlights one of the biggest challenges in modern automotive repair: the gap between mechanical engineering and software control. In this case, the rebuild team has already overcome almost every physical challenge, from structural damage to engine restoration. However, the final barrier is digital, not mechanical. This makes the situation unique because it shifts the final success of the project away from hands-on engineering and toward access permissions and software systems. At the same time, broader industry changes are beginning to